student. I Neha Yadav, Assistant Professor in ABES Engineering College, Ghaziabad. Today I am going to teach first topic of Unit 4 of Discrete Structure and Theory of Logic. The topic is Algebraic Structure. So what is a algebraic structure? A algebraic structure is a non-empty set which is equipped with a binary operator. A binary operator is a operator which deals or which works on two operands. So this is a non-empty set and this is a binary operation. Yeah, operator. This binary operator can be addition, can be multiplication, can be addition modulo something or multiplication modulo something. So a non-empty set when combined with a binary operator, then this is called algebraic structure. An algebraic structure have to follow a property which is known as closure property. So what is a closure property? The closure property says that if we apply this binary operation on any two element of this set, then the result of the application of this binary operation should belong to this particular set. For example, if we consider the set of natural number, if we consider a set of natural number with addition operation, then on applying addition operation on any of two natural number, if we are getting a natural number, then closure property will be satisfied. And we all know that if we add any two natural number, we will always get a natural number. So this is a algebraic structure. Coming to some example of algebraic structure, here are three example of algebraic structure. First example, as I already discussed, if we take set of natural number with addition, it will always be a natural number. For example, if we consider two natural number, any two natural number we can take, it can be 1020. If we add these two natural number, we will get 1020, which will all is a natural number. If we consider any other natural number, for example 20 and 30, if we add these two natural number, we will get 50, which is again a natural number. So if we apply addition operation on any two natural number, we will always get a natural number. The second example is when we apply addition operator on set of integers. So again, if we apply addition operator on set of any two integer, we will get a integer. Integer, we can consider any two integer 20 and 30. These are two integer. We will again get a integer. If we are taking minus 50 plus 20, we will get minus 30. And minus 30 is again an integer. So Z with set of integer with addition operation is always a algebraic structure. The last example is a set of real number. This is a set of R is a set of real number which is equipped with plus as well as multiplication. For this, we have to check, first of all, we have to check real number with addition and then we will check real number with multiplication. So real numbers are all the numbers which are on number line from 0 to whatever digit we are considering. So here real number are all the numbers on number line. We have to consider the decimal values also. So if we consider two real number, for example 1.7 and 2.3, we will get answer as 4, which is also a real number. So if we add any two real numbers, we will always get a real number. So this is a algebraic structure. If we talk about real number with multiplication, if we are going to multiply 0.2 with 0.6, we will get 0.12. So 0.12 is also a real number which will belong between 0 to 1. So these all natural number with addition, integer with addition, real number with addition as well as multiplication are all algebraic structure. This is an important example of algebraic structure. Here the set is given is this. This means this set will consider all the values from 0 to 5. And here is the operator. This operator is known as addition modulo 6. Addition modulo 6. So, for if we are given, the set given is finite set, we can also prove this system or this combination is algebraic structure using the closure table. So here I will draw the closure table. How a closure table will be drawn. These are the, first of all, write the operator over here. These are the elements 1, 2, 3, 4, 5. Here also write again 1, 0, 1, 2, 3, 4, 5. So how we will complete this table? Simply how we will apply closure table. Simply what we are going to prove, this is this a algebraic structure or not? So we have to apply this operation. How this operation works? This operation is addition modulo 6. It means when we add any two value, if we consider any two value from this given set, I am considering 1 and 3. So how to use, I'm just telling you how to use this operator. If we add 1 and 3 and then we find remainder with 6, what will be the remainder? We will get 3 as the remainder. So applying addition modulo 6 on 1 and 3, we will get 3 as the answer. We simply need to add these two terms and find the remainder when we divide that particular addition with that particular term given over here. So this is addition modulo 6. So we will divide each addition result with 6 and whatever the remainder we will get will be the answer. I am considering one more example. If we apply addition modulo 6 with these two values, we will get, for example, when we simply add 4 and 1, we will get 5, and when we divide 5 with 6, we will simply get 5 as the remainder. Considering one more example, 4 plus 3, we will get 7. And if we divide 7 with 6, what will be the remainder? We will get 1 as the remainder. So this is the way how the addition modulo operator works. So here we will complete our this closure table. This is known as closure table, just to check whether this structure is following the closure property or not. So first of all, we will take these two elements. Here it is 0 plus 0. So 0 addition modulo 6, 0. So we will first of all add these two terms and then divide the addition with 6. Whatever will be the remainder, we will write here. So when we add 0, 0 to 0, we will get 0. And when we divide 0 to 6, we will get 0 as the remainder. Similarly, now we will add 0 with 1 and divide it by 6. We will get remainder as 1. So I am completing this table. 0 plus 2 is 2 and dividing by 6, we will get remainder as 2. Here I will get remainder as 3. Here I will get remainder as 4 and here I will get remainder as 5. Similarly, I will add 1 and 0 and find the remainder. So here I will get remainder as 1. Here I will get remainder as 2, 3, 4, 5. And now 5 plus 1 is 6. And when we divide 6 with 6, we will get remainder 0. Now complete the table similarly. 2 plus 0 is 2, 3, 4, 5, 0, 1. 4 plus 2 is 6 and 6 divided by 6 will give the remainder 0. 5 plus 2 is 7 and when 7 is divided by 6, we will get remainder 1. Now 3, 4, 5, 0, 1, 2. 4, 5, 0, 1, 2, 3. 5, 0, 1, 2, 3, 4. So this is the closure table. Now we will check whether the closure property is satisfied or not. We will check all the resultant value, all the values in this table. Is any value in this table is out of this set? Is any value is other than 0 to 5? So when we will check from here, we are not getting any value which is other than 0, 1, 2, 3, 4 and 5. So this combination or this set follows the closure property, so it is a algebraic structure. So if I'm going to if I brief this whole lecture, we have studied algebraic structure. An algebraic structure is simply a set which is equipped with a binary operator. It should follow a property which is known as closure property. Closure property is simply if we apply this binary operator on any two elements of this set, we should get a element which should belong to this set. So if this property satisfies, then this structure is known as algebraic structure. Thank you for patience listening. Thank you so much.